Hello everyone. This is Reddy, Assistant Professor in Mathematics, Reddy, Institute of Technology and Management. Today my topic is linear differential equations from the subject DEVC, the differential equations and the vector calculus. So first of all, what is the differential equations and what is the standard form of linear differential equations? So here the definition is a differential equation of the form dy by dx plus p into y equals to q is a linear differential equation in y. This is a general form of the linear differential equation in y. Also, here the dy by dx occurs with the first order derivative. So this is a linear differential equation in first order and first degree. And also, whereas the functions p and q, both the functions p and q both are the functions of independent variable x. In this differential equations, the derivative will be dy by dx. In the derivative, the upper variable y, here y is called dependent variable and the derivative here x is called independent variable. So that here the functions both p and q, both the functions are independent variable x only, right? Next. So how to solve the linear differential equation? Here is the working rule. How to solve the linear differential equation? Right. So the first step will be whatever a given differential equation is given, first of all, rewrite into standard form. So whereas the standard form will be dy by dx plus p of x into y equals to q of x. This is the standard form of linear differential equation in first order and first degree. Okay. After rewriting the standard form, first identify the functions p and q. In the both the functions are functions of independent variables. Here the independent variable will be x. If you are writing the differential equation in different way, suppose if you are writing like this, dx by dy plus p into x equals to q. This is also a linear differential equation, but in which variable? In the variable x. Because here x will be the dependent variable and y will be the independent variable. Right? So in this case, in this differential equation, whereas p and q, both the functions are independent variable of y. That means p is a function of y variable and q is a function of y variable. Right? Okay. After identifying the functions p and q, next, third step, find the integrating factor. Or integrating factor, this is e to the power of integration of p into dx. This will be the integrating factor. Here just find the integration and you will get e to the power of something. That will be the integrating factor. After finding the integrating factor, next, the general solution is given by this y into integrating factor that equals to integration of q into integrating factor into dx plus c. So this is a step-by-step working rule for solving the linear differential equations in first order and first degree. Now let's discuss example based on this. Right. This is an example based on the linear differential equation. Right. So we will find the solution for the differential equation x cos x into dy by dx plus x into sin x plus cos x equals to 1. This is a given differential equation. But this given differential equation is not in the standard form of a linear differential equation. We need to rewrite. That means here we need to rewrite means here we need to eliminate x into cos x. This is a multiplier for dy by dx. So compared to standard form of linear differential equation, that will be dy by dx plus p into y equals to q. This is a standard form. There is nothing will be a multiplier. So here we need to eliminate this. Right? And here small mistake here it will be y. So first of all here we need to eliminate this. Okay. So given differential equation is x cos x into dy by dx plus x sin x plus cos x into y equals to 1. This is a given differential equation. Now here we need to eliminate x cos x. So divide with x cos x on both sides. So we are dividing with x cos x. X cos x by x cos x into dy by dx plus x sin x plus cos x by x cos x into y equals to 1 by x cos x. Right? So your x cos x and x cos x both will be cancels. Remaining is dy by dx plus here we need to rewrite the two terms. Then the first term becomes tan x plus second term becomes 1 by x into y equals to 1 by x cos x. Take number 2. Now this is a standard form of linear differential equation in y. Right? So which is a linear differential equation in y. Now comparing with the standard form, whereas the two functions p that equals to tan x plus 1 by x and q equals to 1 by x into cos x. Right? Okay. After identifying the two functions p and q, now we need to find the integrating factor. Therefore, integrating factor is e power of integration of p into dx. This is equals to e power of integration of tan x plus 1 by x into dx. Now, e power of integration of, what is integration of tan x here? Right. Or integration of tan x here, that is the log of secant x. And plus integration of 1 by x will be log x. And this becomes e to the power of log of something plus log of something. That becomes log of x into secant x. Now your exponential log both will be inverse functions, so cancel them. The remaining is x into secant x. So this will be our integrating factor. After finding the integrating factor, now the general solution will be, therefore, the general solution of 1 is given by thus y into integrating factor that equals to integration of q into integrating factor into dx plus c. Then y into, now what is the integrating factor here? That will be x into secant x. That equals to integration of q. What will be the q? Here the function will be this 1 by x cos x. 1 by x into cos x into integrated factor. That will be x into secant x into dx plus c. Now in the left side it will be same, x into y into secant x, no changes. In the right side just we need to evaluate this integral. Now x and x cancel. Then the remaining is integration of 1 by cos. 1 by cos can writing as secant. Secant into secant becomes secant square x into dx plus c. Now integration of secant square will be tan x plus c. That's xy into secant x. This is our required solution, which is the required solution, where c is an arbitrary constant. Where c is an arbitrary constant. Right? Next. Now here one more example. This is a given differential equation. Now the given differential equation is dy by dx plus 2x into y equals to e power minus x square, take number 1. And the given differential equation is already looking like linear differential equation in y, right? Which is a linear differential equation in y. Now compare with the standard form of linear differential equation. What is the standard form here? That is, the standard form will be dy by dx plus p into y equals to q. This is the standard form of the linear differential equation. Now here what is the y coefficient here? P. Now comparing to this, where p equals to 2x and q equals to, that will be equals to q. So here what is equals, that is the a power minus x square. That will be the q. After identifying the p and the q, the next step is find the integrating factor. Find the integrating factor. That is e power of integration of p into dx. That equals to e to the power of integration of 2 writing outside and the x into dx. That equals to e to the power of 2 into integration of x will be x square by 2. 2 and by 2 both cancels. The remaining is e to the power of x square. E to the power of x square will be our integrating factor. After finding the integrating factor, next we need to find the general solution. So therefore, the general solution of 1, is y into integrating factor, that equal to integration of q into integrating factor into dx plus c. Then y into integrating factor will be e power of x square, that equals to integration of, or a q, q will be e to the power of minus x square into integrated factor is a power of x square into dx plus c. Now here e to the power of minus x square and here e to the power of plus x square. Here the bases are equal, so power should be added. The power should be minus x square and plus x square. Both will be cancelled. Remaining is e power 0. Then the remaining is y into e to the power of x square equals to integration of 1 into dx plus c. Because e power 0 equals to 1. Now the integration of 1 will be x plus c. So y into e to the power of x square plus c. That's it, which is our required solution. Which is the required solution. Where c is an arbitrary constant. C is an arbitrary constant. Okay.